My today's topic is proving irrationality of irrational numbers. You know what is an irrational number? A number which cannot be written in the form of p by q, where p and q are integers and q is not equal to 0, is called an irrational number. For example, root 2, root 3, root 5, root 6, etc. are irrational numbers. These are irrational numbers because they cannot be written in the form of p by q. So here we are going to prove that these are irrational numbers. The method used for proving the irrationality of root 2, root 3, root 5, etc. is proof by contradiction. What is proof by contradiction? Consider the question. Prove that root 2 is irrational. Here we use the method of proof by contradiction. If possible, let root 2 be rational. Since root 2 is rational, let root 2 is equal to p by q, where p and q are integers, q is not equal to 0, and p and q are co-prime numbers. You know what are co-prime numbers? Two numbers are said to be co-prime if they have no common factor other than 1. Here, if we have a rational form for root 2, then it is equal to p by q. P and q are integers and q is not equal to 0, and p and q are co-prime, means p and q have no common factor other than 1. P and q should not have any common factor other than 1. From this statement we have p is equal to root 2 into q by cross multiplication. On squaring we get p square is equal to 2q square. P square is equal to 2q square means p square is a multiple of 2, because 2 into any expression, 2 into anything is always a multiple of 2. P square is a multiple of 2. If p square is a multiple of 2, then p is also a multiple of 2. For example, 4 is a multiple of 2. 4 is a multiple of 2. 4 means 2 square is a multiple of 2. Therefore, 2 is also a multiple of 2. Another example. 16 is a multiple of 2. 16 means 4 square is a multiple of 2. That means 4 is also a multiple of 2. Therefore, if p square is a multiple of 2, p is also a multiple of 2. We don't know what is the value of p, but we know that p is a multiple of 2. Since p is a multiple of 2, we can write p is equal to 2m, where m is any integer. Squaring, p square is equal to 4m square. But p square is equal to 2q square, therefore we can replace p square with the 2q square, which is equal to 4m square. Dividing both the sides by 2, we get that q square is equal to 2m square. Q square is equal to 2m square means q square is a multiple of 2. Hence, q is also a multiple of 2. So, from the first statement and second statement, it is clear that p and q both are multiples of 2. That is, 2 is a factor of both p and q. From 1 and 2, it is clear that 2 is a factor of both p and q. This is a contradiction to the fact that p and q are co-prime numbers. Therefore, our assumption is wrong. That is, root 2 is irrational. Here, we started with the assumption that root 2 is rational. If root 2 is rational, then p and q must be co-prime numbers. But here, we are reaching to the conclusion that p and q are not co-prime. So, this is the contradiction because of our wrong assumption. So we accept that our assumption is wrong. So root 2 is irrational. So this is how to prove that root 2 is irrational. Similarly, you can prove root 3 is irrational, root 5 is irrational, root 6 is irrational, root 7 is irrational, etc. etc. To prove root 3 is irrational, you will follow the same steps, but the only change is instead of p is a multiple of 2, you will get p is a multiple of 3 as well as q is a multiple of 3. That is, p and q have a common factor 3. To prove root 5 is irrational, you will have to show that p and q both are multiples of 5, hence 5 is a factor. Similarly, you can prove the irrationality of any such numbers. Now look at the question. Prove that 7 root 5 is irrational, given root 5 is irrational. We have to prove that 7 root 5 is irrational. Here also we will use the method of proof by contradiction. Look at the proof. If possible, let 7 root 5 is rational. If it is rational, we can write 7 root 5 is equal to p by q, where p and q are integers, comma q is not equal to 0, and p and q are co-prime numbers. Here, on taking 7 to RHS, we get root 5 is equal to p by 7q. Now look at this part, p by 7q. This is rational because p, q and 7 are integers. So p by 7q is rational. But root 5 is irrational, that is given. This is a contradiction. LHS is irrational and RHS is irrational. So this contradiction proves that our assumption is wrong. Hence, we accept that 7 root 5 is not rational and it is irrational. Now look at another question. Prove that 3 by 2 root 5 is irrational. If possible, let 3 by 2 root 5 is rational. If this is rational, let 3 by 2 root 5 is equal to p by q, where p and q are integers, q is not equal to 0, and p and q are co-prime. Here on cross multiplying, we get 3 into q is equal to 2 root 5 into p. Taking 2 and p to LHS, we get 3q is equal to 3q by 2p is equal to root 5. Here 3q by 2p is rational because p, q, 2 and 3 are integers, but root 5 is irrational. That is, LHS is rational, RHS is irrational. This is the contradiction. That is, our assumption is wrong. Therefore, 3 by 2 root 5 is irrational. See another question. Prove that 5 minus 2 root 3 is irrational by the method of proof by contradiction. If possible, let 5 minus 2 root 3 is rational. If 5 minus 2 root 3 is rational, let 5 minus 2 root 3 is equal to p by q, where p, q are integers, q is not equal to 0, and p and q are co-prime numbers. Here, minus 2 root 3 is taken to RHS and p by q is taken to LHS. We get 5 minus p by q is equal to 2 root 3. On simplifying, we get 5q minus p whole divided by q is equal to 2 root 3. Taking 2 to LHS, 5q minus p by 2q is equal to root 3. Here, LHS is equal to 5q minus p by 2q, which is rational because p, q, 5 and 2 all are integers. But RHS is equal to root 3 is irrational. This is a contradiction. That is, our assumption is wrong. Therefore, 5 minus 2 root 3 is irrational. Now look at another question. Prove that root 5 plus root 3 is irrational, given root 15 is irrational. Here, if possible, let root 5 plus root 3 is rational. Therefore, root 5 plus root 3 is equal to p by q, where p and q are integers, q is not equal to 0, and p and q are co-prime. Here both the terms are under root. So here we have to use another method. We cannot prove it directly. So first we take the square on both the sides. Taking square on both the sides, we get root 5 plus root 3, the whole square is equal to p square by q square. Root 5 plus root 3, the whole square is expanded by using the formula a plus b the whole square, which is a square plus b square plus 2ab. We get root 5 square plus root 3 square plus 2 into root 5 into root 3 is equal to p square by q square. Root 5 square is 5. Root 3 square is 3. 2 root 5 into root 3 is 2 root 15 is equal to p square by q square. 5 plus 3, 8 plus 2 root 15 is equal to p square by q square. Here 8 is clearly a rational part, so I take 8 to RHS. So 2 root 15 is equal to p square by q square minus 8. Simplifying the RHS, we get 2 root 15 is equal to p square minus 8 into q square whole divided by q square. Here q square is the LCM. And taking 2 to RHS, we get root 15 is equal to p square minus 8q square whole divided by 2q square. Here LHS is equal to root 15 is irrational, it is given. But RHS is equal to p square minus 8q square by 2q square is rational because p, q, 2 and 8 are integers. This is a contradiction. That is, our assumption is wrong. Hence, root 5 plus root 3 is irrational.